Welcome friends. In this module we discuss meaning and scope of statistics. Bioinformatics is an application of techniques from computer science to problems from biology. It is interesting because it encompasses important problems, it involves massive quantities of data, and there is desperate need for efficient solutions. In the present time, we often experience a data explosion. Our genetic identity is encoded in long molecules made up of 4 basic units: the nucleic acids, adenine, cytosine, guanine, and thymine. To first approximation, DNA is a language over a 4-character alphabet A, C, G, T. Complete set of chromosomes that determines an organism is known as its genome. Measuring gene expression is a crucial aspect of bioinformatics. The most commonly used bioinformatics data are DNA bar RNA microarrays and their variants. RNA sequence arrays use the next generation sequencing technology. Statistical tools for analyzing gene expression data are differential gene expression analysis, differential gene association or co-expression analysis, gene set enrichment analysis, gene cluster analysis, principal component analysis, and discriminant analysis. Before learning the specific statistical methods for bioinformatics, we shall get into the basics of statistics. According to Croxton and Cowden, statistics may be defined as the science of collection, presentation, analysis, and interpretation of numerical data. Now, the science of statistics deeply rooted in almost all branches of knowledge. Sound statistical techniques have been developed to handle all types of data and to reach valid inferences. The support of computer technology geared up the expedition of the science of statistics to become a decision-making tool to many organizations. H. G. Wells commented, "Statistical thinking become necessary nowadays as the ability to read and write. Biology, psychology, medicine, business, management are some of the areas where statistics playing a high role." The word statistics seems to have been derived from the Latin word status or the Italian word statista or the German word statistik, each of which means a political state. It has evidence that in ancient years, government used to collect data of country to get an idea of its manpower and wealth. In ancient India, an efficient system of collecting official and administrative statistics existed during the reign of Chandragupta Maurya. A good record of land and agricultural statistics were maintained during the reign of Akbar. During 17th century, Captain John Grant of London originated the study on the data of births and deaths, which is called vital statistics. After that, computation of mortality tables and calculation of expected life at different ages etc. were studied. Such studies lighten the area of life insurance. Modern statistics came during mid-17th century with the origin of theory of probability by the French school of mathematicians. Later in 18th century, Pierre de Laplace 1749 to 1827 and C. F. Gauss 1777 to 1855 contributed much on the theory of probability by giving strong mathematical foundation. In 19th century, the famous mathematicians of Russian school of mathematics, Chebyshev 1821 to 1894, Markov 1856 to 1922, Lyapunov 1858 to 1918, and many others contributed to the theory of probability. Carl Pearson 1857 to 1936 introduced the idea of correlation analysis and the most important test of significance, the chi-square test of goodness of fit. In 1933, a monograph by a Russian mathematician A. N. Kolmogorov outlined an axiomatic approach based on measure theory forms the basis for the modern theory of probability. Ronald A. Fisher 1980 to 1962, who pioneered in the theory of estimation, analysis of variance and design of experiments, extended the importance of statistics in many fields such as biology, psychology, education, etc. R. A. Fisher, who is the real giant in the development of the theory of statistics, is known as the father of modern statistics. Scope of statistics in biological and medical sciences. In this session, we are limiting our discussion on the scope of statistics in biological and medical sciences. The biological theories and statistics were connected first by Francis Galton in his study on regression analysis. In medicine, statistical data analysis is essential to relate observed facts to causes and incidence of diseases. The branch of statistics deals with the data derived from the biological, medical and health sciences is termed as biostatistics. Biostatistics is also called biometry, which is literally means biological measurement. Clinical trial, which is an experimental study involving human subjects, are conducted before marketing a new drug. The data from this study is to be analyzed to conclude whether the drug is effective and safe or not. Statistical data collection and inference based on the collected data is common in variety of topics of health science. For example, if we wish to study the effects of a new diet, we might begin by measuring the changes in body mass over time for all individuals who have been placed on the diet and to be analyzed. The survival time of an AIDS patient after diagnosis of the disease can be estimated by analyzing the relevant data on AIDS patients. Similarly, the questions like whether a positive lab test actually indicates the disease or what is its chance, whether mortality of male and female are same, etc., can be answered using the statistical analysis of appropriate data. The raw material for any statistical study is the information collected called data. A statistical investigation is performed with following steps. 1. Planning the inquiry. 2. Collection of data. 3. Organization of the data. 4. Presentation of the organized data. 5. Analyzing the presented data. And 6. Interpretation of the collected data. In a statistical investigation, organize and summarize the data, which is coming under descriptive statistics, and reaching decisions about a large body of the data by examining only a small part of it is coming under inferential statistics. Population and sample. Consider a large group of individuals. Assume one particular characteristic of this large group is to be studied. For example, we have to study the weight of boys of 15 years old in a state. Here we are considering the large group of boys of 15 years old of the particular state, and we are focusing on the weight of these students. Any boy of the particular state of this group is capable to provide us the required data. The large group of students considering here is referred to as the population under this investigation. As a definition, we can say the large group of entities which is capable to provide the information required under the statistical investigation is the population under investigation. A sample may be defined as a part of a population. In our study regarding weight, if we are selecting only a few students and measuring their weights, the data obtained is a sample data. Let x denotes the weight of a student of this group. Corresponding to each individual of the population, we get a number denoting the weight of that student. The set of such numbers are called statistical population. This statistical population is the set of admissible values of the variable x, the weights. If the population under a statistical investigation consists of a finite number of values, it is termed as finite, otherwise it is an infinite population. Collection of data. Systematically collected data is the backbone of any statistical investigation. Statistical data are generally of two kinds, one primary data and two secondary data. Primary data. Primary data are those statistical data which are collected for the first time and are original in nature. The investigator or the enumerators appointed by him collect data directly from the units of the population to perform their statistical analysis. Secondary data. Secondary data are those type of data collected by some other agency for similar purpose and used by the investigator for his purpose. Office records, government publications, publications of research institutions, newspapers, etc. are the sources of secondary data. Collection of secondary data is less time consuming and cost saving, but extra care should be given while deciding the compatibility and reliability of the data. But it is to be remembered that once it was the primary data for some other. Primary data is original, but expensive and time consuming. If it is collected in a systematic and efficient way, it is much dependable. Methods of collecting primary data. Various methods of collection of primary data involves 1. Direct personal investigation. In this method, the investigator or enumerator personally collects the data from the units of the population. This type of data collection advised when the area of investigation is limited and high degree of accuracy is needed. Number 2. Indirect oral investigation. Here the data are collected from the persons not directly concerned, but from a third party who can provide the enough information. This method is adopted when the informant is unwilling to give the required information. 3. By sending questionnaires. When the area of investigation is vast and informants are literate, one can send questionnaire containing the questions on the information required to the informants and collect the required data from their answers to the questions. Success of this method mainly depends upon the ability of preparing a good questionnaire and the degree of response from the informants using the help of correspondence. Apart from the formal data collection, agencies or correspondents are appointed in different areas to collect and transmit the required information. Census and sampling. If the data is collected from each and every units of the population, then it is known as complete enumeration or census. When the enumeration is made only from a part of the population, it is called partial enumeration or sampling. Sampling is divided further into probability sampling and non-probability sampling. If the sample items from the population for enumeration are selected according to some probability law, the method is probability sampling. If the samples to be enumerated are selected according to the convenience of the enumerator, the method is non-probability sampling. Simple random sampling, stratified sampling, systematic sampling are some of the probability sampling methods. The possible errors in data collection are classified into sampling and non-sampling errors. The errors arising due to the faulty and unscientific methods used in sampling procedure and errors in the inference drawn about the population on the basis of the sample are coming under sampling errors. The manual errors while data processing due to carelessness or untrained persons are coming under non-sampling errors. Types of data: qualitative and quantitative data. Qualitative data is a categorical measurement expressed not in terms of numbers, but rather by means of natural language description. In statistics, it is often used interchangeably with categorical data. Quantitative data is a numerical measurement expressed not by means of a natural language description, but rather in terms of numbers. Quantitative variables can be continuous or discrete. Continuous variables are the variables which can assume any real number within certain limits, and discrete variables are the variables which can assume only finite or infinite but separable possible values. Weight, height, etc. are continuous and they can assume any value within a given range. Examples of discrete variables are number of children in a family, number of attacks of asthma per week, etc. Categorical variables are either nominal, unordered or ordinal, ordered. Examples of nominal variables are male, female, alive, dead, blood group O, A, B, AB. For nominal variables with more than two categories, the order does not matter. For example, one cannot say that people in blood group B lies between those in A and those in AB. Sometimes, however, people can provide ordered responses such as grade of breast cancer, or they can agree, neither agree nor disagree, or disagree with some statement. In this case, the order does matter and it is usually important to account for it. Ranked data. In some situations, we arrange a group of observations from highest to lowest according to the magnitude and then assign numbers that corresponds to each observation's position, which is called rank in the sequence. This type of data is called ranked data. Attributes and variables. Consider the recorded heights of 4 individuals in inches as 51, 52, 71 and 76. Here height is a variable and the figures 51, 52, 71 and 76 are the values of the variable. Suppose we select a packet of 4 bulbs. The lot contains good as well as defective bulbs. The box may contain 0, 1, 2, 3, 4 defective bulbs. The values 0, 1, 2, 3 and 4 are the values of the variable. Out of 4 persons whose heights are given above, 2 are tall with height 71 and 76 inches and 2 are short with heights 51 and 52 inches. Here level of height, tall or short, is not a variable. It is called an attribute. Out of 4 bulbs, 2 are good and 2 are defective. Here also any variable is not under consideration. The status of the bulb is an attribute with 2 outcomes, good and defective. Thus, attribute is a quality and the data is collected to see how many objects possess the quality of being defective and how many elements do not possess this quality. Other famous examples of the attributes are level of education, level of smoking, religion and color, etc. Hence, the data on the variables are called the quantitative data, whereas the data on the attributes are called qualitative data or count data. Limitations of statistics. Even though the science of statistics is a powerful tool to solve many decision making problems, it is having some limitations also. Some important limitations of statistics are: 1. Statistics does not study individuals. Statistics deals with those problems where the characteristics of a group are considered. It does not give any specific recognition to the individual items of a series. Statistical results reveal the average behavior of the general trend. Hence, they are used for general appraisal of a phenomenon. 2. Statistics does not study qualitative phenomena. Statistics deals with quantitative characteristics. Qualitative phenomenon which cannot be numerically measured is out of the scope of this science. However, statistical techniques may be applied to qualitative characteristics indirectly by reducing them to appropriate quantitative terms. For example, the qualitative characteristics intelligence of a group is measured by quantifying it using scores obtained in some tests. 3. Statistical laws are not exact. In a statistical study, the predictions are not exact. In some chemical reaction, the result is exactly predicted, but in an experiment of tossing of 2 coins with the help of the probability of occurring heads in the coin, the total number of heads occurring can only approximately be predicted. 4. Statistics is liable to be misused. It is just like a tool which can use only by experts and dangerous in the hands of inexperts. The inference made by untrained persons may be fallacious. Using statistical data, one can produce false inference as he wish, and it can be presented as the truth. In such a context, the words of King that statistics are like clay of which one can make gods or devils as one pleases is relevant. Hence, it is to be ensured that the statistical analysis is done by experts in a scientific way to reveal the truth contained in the data. Now, let us summarize the session. This module is for brief introduction to the world of statistics. Some fundamental concepts and some historical aspects are provided. Various methods of data collection and types of data are explained. The method of census and sampling is included. The concept of attributes and variables are given. Finally, some of the demerits of statistics are also added. Before we attend the next unit, please try to answer the following questions. 1. List out some situations where statistical investigation is needed in biological sciences. 2. Differentiate between descriptive and inferential statistics. 3. Prepare a short note on primary and secondary data. 4. Write a note on various types of data. The books for your reference are 1. Marcelo Pagano and Kimberly Gauvreau, Principles of Biostatistics, Cenage Learning. 2. Mehdi J. Statistical Methods and Introductory Text, New Age International Private Limited. 3. Bud B.R., Sri Venkatramana T. and Madhav Rao K.S. Statistics, a Beginner's Test, New Age International Private Limited. 4. Gupta S.C. and V.K. Kapoor, Fundamentals of Mathematical Statistics, Sultan Chand and Sons. 5. Daniel W. W. Biostatistics, John Wiley Sons. Hope you enjoyed this session. See you next time. Until then, goodbye.